We're looking for the missing side here. We're using Pythagorean Theorem. I put this on here because we're going to be using Pythagorean Theorem on a little bit of the stuff that we're doing today. So I'm looking for this side of this triangle. Now, in our Pythagorean Theorem, a squared plus b squared equals c squared. Is this side the AB or C side? It's the C. It's the hypotenuse. Okay, I've talked about this a little bit, but we're definitely going to do it like this today, is just using the little shortcut. So on this, you would just do 48 squared plus 55 squared and take the square root of that. When you're looking for the hypotenuse, you add here. If you know the hypotenuse, you're looking for one of the shorter sides, you subtract. Which, I mean, it's easy to think about. Since you're looking for the longest side, that's why this is addition. If you're looking for one of the shorter sides, that's when you subtract. But this just gives you a whole number. So if you just plug this directly in your calculator, square root of 48 squared plus 55 squared, what does that give you? Okay, it gives you exactly 73. Okay, this one's the same thing, 33 squared plus 56 squared square rooted. What does that give you?
65.
Okay, gives you 65. Okay, how do we find the area of a regular polygon?
A times P divided by 2.
Very good. The apothem times the perimeter divided by 2. So how long is the apothem of this octagon?
14.5.
14.5 times, what would the perimeter be?
96.
It'd be 12 plus 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 12, which is 96 divided by 2. So we have the apothem times the perimeter divided by 2. What does that give you?
696 squared.
Okay, say it one more time. 6 what?
696 squared.
Oh, it's just straight up 696?
Yeah.
Okay. Yep. Very good. And then on this one, the apothem is 5.1 times the perimeter, 7.5 times 5, divided by 2. What does that give you? 5.65? 3? 5?
6.3.
Okay. Okay, so today what we're going to talk about is lateral surface area and total surface area of pyramids and cones. Last week we spent the whole week on prisms and cylinders, which, you know, prisms and cylinders. This week we're talking about pyramids and cones, which it's kind of weird because, I mean, those both start with the P, these both start with the C, so it's easy to get these confused. Prisms and cylinders, pyramids and cones. So, I mean, the shapes are obviously very different, but it's easy to get those names kind of confused sometimes. But we're basically going to kind of do the same thing this week that we did last week. It's going to spend a couple days on surface area of pyramids and cones, and we'll talk about volume of pyramids and cones, and then do some reviewing at the end of the week this week. Okay, so let me just give you the formula here. So for total surface area of a pyramid, it's P times L divided by 2 plus B. And we're going to talk about these variables in just a second. Then for lateral surface area, it's P times L divided by 2. Now, most of these variables mean the exact same thing as what they meant with the prisms and cylinders. So what does the capital P stand for? Okay, good. So the capital P stands for perimeter of the base. So like perimeter of the base would be adding this, 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 and this, which in that case, what would the perimeter of that base be?
12.
It would be 12, just adding those up. Okay, on this one, would be adding this, 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 and this. What would that perimeter be?
55.
Would be 55. It's 11 5 times. Okay, on this one, the perimeter would be adding this, 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 and this. What would that be?
16.
Would be 16. And I shouldn't put that cone on that one. Ignore that. I mean, we could talk about the circumference, but we really don't need that. Okay, what does the capital B stand for? Okay, good. Same thing as last week with prisms and cylinders. It stands for area of the base. Okay, so on this one would be the area of that base. What would the area of that base be? Be 9 square millimeters. Okay, on this one we'll be looking for the area of this pentagon, which would be 7.6 times 55 divided by 2.
209.
Say again?
209.
209. On this one, capital B is the area of the base. We're looking for the area of that one, which would be 16. Okay, so the P and B mean the same thing as last week. The new variable we have for this week is this little L, okay? Written as a cursive L. So, what do you think L would stand for?
From the top of the cone to the bottom of the latitude.
Okay, I heard somebody say length, and that's a very good guess. That definitely would make sense within this context, but that's not it. I heard somebody say something about lateral area. That would make total sense again within this context. That's not what it means. And the thing is, you'd never guess what this L stands for. Okay? So I don't know why they used L for this, but here's what the L stands for, and it is slant height. Yep. It's one of those things like, what? Why would you even do that? But that's what it is. The L stands for slant height. Now, as you look at this first square pyramid right here, this line going from here to here, okay, that right there is the height. That is just the height, just the H. This, from here to here, that is the slant height. Which, I mean, the L meaning slant height, that's hard to see the correlation there. But the slant height, I mean, the phrase slant height makes sense for what's going on. It's the height that's on the slant. So that does make sense. So on this one, the 11 millimeters is the slant height for this pyramid. Okay, on this one, the 12.5, this one is the slant height for that pyramid. On this one, right here, this is the slant height again. 6.3 is the slant height for that pyramid. Now for a cone, this does apply, which I mean, for those others it applied, but this really is the same thing here. The 12 would be the slant height for this one. Now, again, and we'll see this as we go through here today, that right there going straight up from the top down to the center of it would be the height. The 12 is the slant height. All right, for a cone, here's our formula. For total surface area, it is pi RL plus pi r squared. And for lateral surface area, it's pi RL. Now, we talked about this last week. I wanted to talk about it some more this week. Just continue to talk about it. But what's the difference between total surface area and lateral surface area?
Lateral is everything but the bases.
Okay, good. The lateral surface area is the area without the bases. Whereas the total surface area is the area of everything. Which, I mean, that makes total sense because why is, thinking about this, why is there this difference in these formulas? What is the area of the base for a cone?
Pi r squared.
The pi r squared, because remember in a cone, the shape of the base of a cone never changes. It's always a what? A circle. A cone always has a circular base. And so this is the way you find the area of that base. And so that's why we have the difference in these two formulas. Is the lateral surface area here does not include the area of that base, pi r squared. Okay. So let's flip it over. And on example 1 here, what does the capital P stand for? Perimeter of the base. We have 14, 14, 14, and 14.
56.
56.
That one or is that the height?
Yeah, this should be a little cursive L.
No, I'm saying the 24.
Oh, yeah, okay, that's what we're about to talk about. Okay, so what does the L stand for? The slant height. Is the 24 the slant height? No, the 24 is the straight up height. The slant height is going to be right here. Okay, so what I'm going to do is I'm going to redraw this triangle. Do it, this trash. Okay, so what I did is took this little triangle that's inside this pyramid here, and I just redrew it right here. So how long is this side of this triangle? It's 24, the same thing as that right there. Okay, now how long is this side going to be?
7.
Okay, why is it 7?
Because that's half of
Good. If you think about what's happening here, the way this height is, it drops in right here exactly halfway. So it's halfway of the 14. So it's going to be half of 14, which is going to be 7 right here. And now I'm looking for this. That's the slant height. So we're going to do the square root of 7 squared plus 24 squared. And what does that give you?
25.
Okay, it gives you 25 exactly. Okay, now what does the capital B stand for? Area of the base. So the base is just a square. So we're going to do 14 times 14, which is 196 meters squared. Now for lateral surface area, we're going to do P times L divided by 2. $700. Now, we're going to use the formula in just a second, but let's just use some common sense here. What's the difference between lateral and total? The lateral does not include the area of the bases. In this case, for what we're doing with pyramids and cones, there's only one base. So the difference between the lateral and total is just the area of the base. So the area of the sides of the faces is 700. If the area of the base is 196, what's going to be the total? Yeah, it would just be those two together. It would just be 896, right? The answer here is 896. But then if we use the formula, I mean, it's the same thing. You're going to see 56 times 25 divided by 2 plus 196 gives you that. Okay. So I forgot. Let's talk about this. What is this shape right here? What kind of pyramid is it? Okay, rectangular pyramid would be good, but we can be more specific here. Okay, good. This is a square pyramid. All right, example 2. First of all, what is this? Okay, good. This is a hexagonal pyramid. All right, so what does the capital P stand for? Perimeter of the base. So what's the perimeter of this base? 66. I mean, assuming this is a regular hexagonal pyramid, and it is, it's 11 plus 11 plus 11 plus 11 plus 11 plus 11. So this is 66. All right, for the slant height. All right, this line right here is 18. Our slant height is doing like this.
Same thing.
Nope. It's not the same. So, how far would it be from here to here? Would be 5.5. Okay, this is 18, this is 5.5, and I'm looking for this right here. So on this, again, Pythagorean Theorem, this time since I know the hypotenuse, okay, I'm looking for a shorter side, I'll be subtracting here. So it's going to be 18 squared minus 5.5 squared. $17.14, we'll say. All right. Now, area of the base. How are we going to find the area of this base? What formula am I going to use? AP divided by 2. Apothem times perimeter divided by 2. Do I know the apothem of the base? Nope. So this is going to be like what we did some of last week. Okay, and I'm just going to cut a little bit more to the chase on this. So on the hexagon base, regular hexagon base, this angle right here is always going to be 60. I'm looking for this side right here. How far is it going to be from here to here? It's 5.5. So from our angle 60, we have the opposite and adjacent. This is going to be tangent. So tan of 60 equals the opposite x over the adjacent 5.5. So I'm just going to multiply 5.5 times the tan of 60. And what does it give you? Okay, 9.53. All right, right there, 9.53. So for the area of the base, we're going to go apothem times the perimeter divided by 2. What does that give you? $314.49. Okay, for lateral surface area, it is PL divided by 2. What does that give you? And then for total, it's PL divided by 2 plus B. What does that give you? Okay, 880.11 square feet. All right. So on the cones, these are easier because they always have the same base. They always have a circular base, so there's less to think about really on these. So what's the radius of this cone? The radius is 12. Okay, is the slant height 15? No, the height is 15. So we've got to find the slant height, which, I mean, you can just see right there that triangle already drawn out for us. So we're going to have 12 squared plus 15 squared square rooted. What does that give you? 19.21. Okay, and on this I have the b. We're not going to worry about that because that's figured into our formula. So on here, we're going to skip the area of the base. And on your assignment, whenever you have the cones, I think the b is on there also. Just skip that on your assignment. Okay, so for lateral surface area, it's just pi RL. So pi times R times L. Pi times the radius times the slant height, and 724.2. All right, centimeters squared. And then for the total, pi R L plus pi R squared. And what does that give you? 1176.59 square centimeters. Okay, that's good enough on that because like I said, really on a cone, I mean the hardest thing there is finding that slant height. The rest of that's just plugging that into the formula. Did anybody have anything different over here on this pyramid? Because everybody's really quiet. Usually when that happens. Is this what everybody got here?
Yes.
Okay.